Hi, I'm Chris Bolgiano, an environmental writer and a lover of forests. Recently, I gave this 10-minute presentation on the Southern Appalachian National Forests at the annual conference of the Appalachian Studies Association. The theme of that conference was Extreme Appalachia, so I thought it would be appropriate to start my presentation with the extreme devastation of our mountain forests throughout Southern Appalachia that occurred from about 1880 to 1930. The massive, destructive exploitation in that half-century left an estimated 1% of the original forest. But I hope to demonstrate that, by an irony of history, what happened in the past offers us today an incredible environmental opportunity. The Weeks Act of 1911 authorized the Forest Service to purchase some of the most devastated mountain lands, stabilize the erosion, and put out fires. The George Washington National Forest, at 1.1 million acres, is the largest national forest in the East and the one that I live adjacent to, but there are 7 more nearly contiguous national forests down the highest ridges of the mountains south to Georgia. Today, we have about 6 million acres of recovering national forests, in essence, a regional, ecosystem-based core of publicly owned forests. And these aren't any forests, but the most biodiverse temperate woodlands in the world, with many species of plants and animals unique to our region. Appalachian residents use these life-sustaining forests as a commons. Magna Carta gets all the press, but the Forest Charter that came right after it legalized, for the first time in history, the ancient right of common people to use forests for grazing, foraging, and hunting. This was the forest commons tradition that Appalachian settlers brought with them. These commons traditions today are now firmly settled onto the National Forest Complex. Millions of people support a multi-million-dollar recreational economy based on our national forests. Plus, we've learned to recognize that there are literally priceless ecosystem benefits of having large, unfragmented swaths of forest cover whole landscapes. Like clean drinking water. The George Washington contains the headwaters of the Potomac and the James Rivers, which supply millions of people. But the GW also lies above the Marcellus shale play. When the land management plan for the George Washington came up for revision in 2011, the gas industry pressured the Forest Service hard to facilitate fracking, which is highly polluting. But more than 75,000 people wrote in support of protecting water supplies, and in 2014, the Forest Service issued a new plan that stopped oil and gas leasing altogether for the next 10 to 15 years that the plan is in effect. The ad on the right shows the widespread gratitude. It was truly a triumph of the commons, contrary to Garrett Hardin's infamous 1968 article called Tragedy of the Commons, which in fact he admitted years later was extremely misleading. So what I'm proposing today is that all 6 million acres of our Appalachian National Forests are offering an enormous commons benefit that we've hardly recognized yet, and that is carbon sequestration. Trees take in carbon dioxide, the major greenhouse gas, from the air during photosynthesis, and make sucrose for cell energy and cellulose as wood. A tree is about 50% carbon. Trees respire at night, giving off carbon dioxide, which is also given off by decaying wood. When there's more photosynthesis than respiration, carbon is stored or sequestered in the wood, roots, and most of all, in soil, which is the largest reservoir or pool of carbon. Now, if carbon sequestration by forests hardly sounds like a hot-button issue, consider this. Forests in the lower 48 states sequester about 15% of America's total carbon dioxide emissions every year. The amount of carbon stored in U.S. forests is equal to 67 years of fossil fuel emissions at today's rate of combustion, and most of that carbon is in eastern forests. Destruction and degradation of forests are the second greatest sources of global carbon dioxide emissions after burning fossil fuel, and forest management is a major component of all international climate agreements. our national forests matter on a global scale. But most of the trees in those forests are about a century old, give or take a few decades. This poses a management question. Is this great native chestnut oak a vigorous tree thriving into old age, capable of centuries more contributions to forest life? Or is it already an aging dodderer, doomed to decline and worth only its wood that should be immediately harvested? Since the 1960s, ecologists have assumed that mature trees reached a balance of photosynthesis and respiration, in effect becoming neutral in terms of ecosystem function. Foresters will tell you that aging trees should be cut, and a younger, healthier forest would then grow up and sequester more carbon. But newer research is completely reversing those assumptions. In 2009, an international team of editors analyzed hundreds of global studies and concluded unequivocally that old-growth forests continued to sequester carbon as strongly as younger forests for at least 600 years. Studies in actual forests, instead of computer models based on assumptions, continue to confirm these results. In 2014, the largest study ever conducted analyzed the growth rate of nearly 700,000 large trees representing 403 different species. Their conclusion is stated in their title: the rate of tree carbon accumulation increases continuously with tree size. Our oaks and hickories can live at least 400 years, and other trees can live even longer. Dendrologist Dr. Stockton Maxwell of Radford University has documented 700-year-old red cedars on a remote cliff in Monongahela National Forest in West Virginia. But for the Southern Appalachians, old doesn't necessarily mean big. The extreme erosion and fires of that earlier era drastically reduced soil fertility, especially on steep slopes. One recent study estimated that trees that regrow on severely degraded soils need, on average, 350 years of leaf fall and root growth to rebuild the same amount of carbon as is contained in more natural soils. Our national forests in the Southern Appalachians could be a carbon sponge for centuries, helping to stabilize our regional environment against climate change as they rebuild soil and age into old growth. Old growth is another area where research has completely reversed the old assumptions that it was a biological desert, as foresters used to call it. Not only has old growth been shown to store enormous amounts of carbon, but it's also a haven for wildlife. These characteristics of old growth show the many dynamic layers and habitat niches that are critical for plants and animals, including the essential soil fungi that can't live in edges or younger forests. Researchers estimate that old growth would naturally occur in scattered patches comprising about 50% of our mountain landscape. The other 50% would be younger due to natural disturbances like wind, our dominant natural disturbance that starts opening the canopy when trees get tall enough to snag passing squalls. Wind generally kills a few trees and opens small canopy gaps for species that need sun to sprout. An ever-increasing number of invasive non-natives, like the chestnut blight, hemlock woolly adelgid, emerald ash borer, to name just a few, also have or are killing many trees and opening gaps of various sizes. Fire can affect large areas, and if hot enough, it will burn soil as well as living trees and send a lot of carbon up in smoke. Timber harvests open large gaps that invite a lot of these non-native species. Plus, they remove some amount of wood and leave some deadwood. New trees that grow up after a harvest or fire can in fact be carbon dioxide sources, not sinks, for decades, because it can take that long for young trees to grow big enough to take in more carbon than is released by decomposing deadwood and the torn-up soil left behind. And for harvests, you have to account for the carbon in the wood removed. Foresters point to high-quality, durable wood products, the kind of furniture that might show up at a 22nd century antiques roadshow, as a way to keep tree carbon fixed long-term. And that's true, for as long as that furniture stays out of the landfill. Once there, the methane released may be worse than the carbon dioxide. The use of engineered wood instead of steel and concrete both of which emit huge amounts of carbon dioxide during manufacture, can also retain forest carbon until those buildings are turned down as part of our endless urban redevelopment. So, calculating the carbon impacts of any management activity is complicated and extremely site-specific. Over the 35 years that I've interacted with the Forest Service as an adjacent landowner to the GW and an environmental writer, I've seen them grow much more conservative in managing our common natural resources. In addition to stopping oil and gas leasing, the 2014 George Washington Plan set aside about 59% of the forest as unsuitable for timber harvest, which is a highly suitable amount of potential old growth according to research. But this area is still subject to prescribed burning as part of those many thousands of acres to be burned annually, as well as roads and development not related to logging. And in the 452,000 acres that are suitable for timbering, several thousand acres will be logged each year, with an increasing demand for biofuels to run electric utilities and heavy pressure from hunters for much more of the young forest that attract deer, grouse, and turkey. Even though oaks don't produce reliable crops of acorns until they're 60 to 80 years old, and acorns are essential for both game and non-game species. Some forecasts warn that climate change will bring drought and wildfires to the Southern Appalachians, and it may well be, as far as service policy states, that prescribed fires or timber harvests can remove fuel and reduce the chance of catastrophic fire with its huge carbon losses. But other forecasts call for more rain than normal. In the face of enormous uncertainties about the future, there's a general agreement among the research papers I read on the same two steps. Longer rotations, which for trees, hardwoods, in the George Washington is now up to 180 years, which is still less than half of the lifespan of most hardwoods. And low-impact harvesting that severely limits disturbance to soil and remaining vegetation. I think it would be appropriate to add carbon calculations of management activities because carbon sequestration is emerging as a critical common service from our national forests. It would be another triumph of the commons if we could make the great Appalachian carbon commons a recognized part of forest management. Thank you.